Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, how dare you, then be sure to subscribe, hit the bell notification icon, and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, crypto, and thanks button in the info box below the video. Most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and X. Now we are joined by 10th Man, Brian's Logic, Arthur, Neil, Righteous, and a whole bunch of people in Discord, so welcome one and all.
Hello.
Hey.
Good morning.
Good afternoon.
Good morning, good afternoon, welcome one and all, good to have you all. Any evidence of a physical geometric sphere edge, that's a horizon formerly known as the curve of the Earth?
No, but there's plenty of evidence that the ballers presume that there's a refracted position based off of this thing that they have never shown. And they're using that all the time in their arguments and not telling people that they're referring to a refracted position.
Any evidence that you can acquire an elevation angle measurement from a curved baseline?
No, you need 3 horizontal planes just to portray it as a diagram.
Julio. Oh, that's going to do for the housekeeping today because we're going to get straight into this video. Who is fairly small subscribed videographer, I should say. But let him know at Nathan Oakley 1980 sent me, and hopefully we've got some positive things to say about this dude. But you'll see his link whizzing on by in the chat right now. So as always, we would hope that he would return the algorithmic love and put a link to our video should he respond. In the meantime, we're going to get into this, and yeah, just let us know in the comments if you've actually let this person know that we sent them.
If you're having trouble setting up triple integrals in spherical coordinates, this video is intended to help you visualize what those 3 spherical coordinates, rho, theta, and phi, look like in 3D space. We're going to start by looking at this point in 3D space. And
I'm sorry about the background noise. If you can hear a faint hum of a V10 engine in the background the entire video, I'm really sorry about that.
the first coordinate we're going to look at is rho. Rho is defined as the distance from the origin, and you can think of it like a 3D radius, or later when we start making solids, this is going to be the radius of our sphere. Theta is measured the same way that it is in polar or cylindrical coordinates, where we start from the positive x-axis and we rotate towards the positive y-axis. You're probably more used to seeing this in 2D space, so make sure that you're starting it at the right position with the positive x-axis and sweeping towards the y-axis. The last coordinate, phi, is the angle measured starting from the positive z-axis.
Hopefully everyone's clear so far. We're basically using a Cartesian grid. Length, breadth, and depth, fairly straightforward so far. Hi, Arwin.
Notice that this description doesn't give us any
Hello.
direction for phi to travel like theta does. What this means is that the same phi can be measured at many different spots around the z-axis. In our example, phi is 30 degrees, but over on this side, phi is also 30 degrees. In fact, all of the points on this cone have the same phi value, 30 degrees, since the angle they form with the positive z-axis is always 30 degrees. Next, let's think about the possible values for our 3 coordinates. Starting with rho, we only want to consider positive values for our distance, so we're going to say that rho has to be greater than or equal to 0. In the diagram, you can see what happens when we let rho fluctuate between 0 and 1. Next is theta, and if we start at theta equals 0 and go up to theta equals 2 pi.
No offense, Tenth, but this is intensely boring.
Yeah, we can't respond to this.
Yeah, well, I mean, there's nothing wrong with it. There's nothing to respond to. I mean, the guy's accurate, but I mean, if Adam was here, he'd be moist. But for me, I'm just thinking about putting this on a tape and sticking it in my bedroom so I can send myself to sleep with it.
Then what we've done is swept in a complete circle, and that circle is going to encompass all of 3D space. So theta is in between 0 and 2 pi. The last one is phi, and this one might be a little bit counterintuitive the first time you see it, but it makes sense if you think about the values of phi.
I mean, we can respond and say, so far, all we're doing is looking at taking flat Earth Cartesian measurements. And in relation to how we would measure these, they're going to be measuring with respect to the X and the Y axis. That's
Right, well, they're just transforming the way the coordinate system works into a circle-centric system, right? Just like they did with the disk Earth map.
Yeah, so you're going to need a flat Earth for that.
Yeah.
Yeah.
Needing to sweep all of 3D space. So if we start at b equals 0 and slowly increase it, we can see this cone almost blooming out of the z-axis until eventually it reaches pi over 2. And when phi is pi over 2, then we've swept all the way down to the xy plane. And so if we then continue to increase phi, then we start to get this cone in the negative z. And at the bottom here, we've swept all of 3D space, but note that phi hasn't gone around in a complete circle. Phi has started at 0, but the angle of phi down at the negative z-axis here at the bottom is equal to pi. So we say that phi is going to be in between 0 and pi. If we put all these together to try and define a solid sphere of radius 1, then we can say that rho is in between 0 and 1.
I got
Theta
a tip, by
is
the
in
way.
between 0
I got a
and 2
question.
pi.
Okay, go ahead.
Can't he just like say this a little bit slower and a little bit more monotonous? Maybe we'll understand it better.
Not that it needs any difference in tone to be understood. What we've got on screen now for the audience's benefit is how all of your coordinate systems are represented when you believe you're on a sphere. That is to say that you've got a flat plane through axis Y and X on screen, and then the coordinates that you will take off a tangent-based fantasy reality that doesn't have GPs, for example, they'll all be transposed down into the center of Earth into that coordinate system that's still based on a flat plane. You've just wrapped this sphere around it of radius 3959 so that you can back engineer all of the transitions through, I don't know, 1 degree for every 60 nautical miles. So all of those transpositions still require that there be a Cartesian grid at the center of this sphere that's been superimposed over the top of that grid system. But the measurements that are going to be referenced for a globe Earth, if they're going to have any technical use, will be taking place in the middle of this sphere, in the three-dimensional Cartesian grid, not on the sphere, as is implied.
Hi.
Well, all he's doing is laying a protractor onto the XY plane.
Correct.
And then using the Z
Exactly.
with the XY plane for points, you know, as points. They call coordinates points.
Exactly.
It's all this can be done. Like they call it spherical coordinates, but it's actually all can be done in 2 dimensions. It's really just because that's all it is, a whole series of 2-dimensional circles that join up together.
Right.
So
the central point of this X, Y, Z coordinate system is you. And then what they've mapped around it, if you ignore the bottom section, the second bottom half of the spherical depiction. So the bottom hemisphere is ignored and you're just left with X, Y, and Z. with a hemisphere over the top of it. That's your protractor. That's you standing with a protractor to everything in your field of view. And then wrapped around you is a sphere Earth radius 3959. And then wrapped around that is the view you get through your protractor. That would be the stars and their angles on this Cartesian grid.
Well, the two-dimensional Cartesian grid always works hand in hand with polar coordinates. Polar coordinates are latitude and longitude, right? That's polar coordinates, which is concentric circles from a center point. Now, that and the XY grid work perfect together, right? All they're doing is taking that concentric circles and giving them an elevation point at different points along that circle. That's all they're doing. They're just turning them up to it and then joining all those circles they have together. The easiest way is if you look at XY, how you read XY. Just look at how you read XY and then just look at how that's converted to polar coordinates. Now, because XY and polar are both flat only, and there's no elevations. And if you look at how that's converted, it's exactly what they're doing, but they're just making it look like it's happening in 3 dimensions.
Indeed.
That's all it is.
Right. So you start with this. Hold on. You start with this on screen. So then assuming that you've got a horizon that has a position for another dome of the heavens over the top of this, but then it won't function. So they have to take this angle measured to nowhere and put it on this flat plane coordinate system with the sun out with the angle coming from this point. But you can then wrap a globe around that. Whoops. You wrap a globe around that coordinate system. So rather than having you on a plane measuring an angle to the sun in this example, you've got you inside a sphere on the same exact grid. But polar, hold on, I'm nearly there, Brian, I'm backing you up. But polar centric. So you've got the pole star at Z in this depiction, and then coming down to the center point where you'd be standing if you were on your back looking up at Polaris. But then the grid that they give is off the X and Y axes, just circles that get bigger and bigger out on that flat plane. That's it. That's all you've got. Yeah, Brian.
Yeah, that's all they're actually doing there. I'll show in a few minutes with GeoGebra, because GeoGebra just show it. They just show it. What they're actually doing is they're taking the X and Y, they're taking, let's just say, a negative Y coordinate. So let's say there's 10 plus Y and 10 minus Y. They're going to minus 4Y, and then they're doing the same with plus 4X. Then they're doing the same with plus 4Y and plus or minus 4X. Right? That creates, and when you use those 4 points, you make a circle out of them. You then can do the exact same thing when you use the Z-axis off of that, which is you're just doing the exact same thing. You're using that. It's circle hijacking. That's all it is. But they're just hijacking two-dimensional coordinate systems that work together, and it's nonsense. All it is points, XYZ points, all matching together. That's all it is.
Nathan, what is the title of the video, please?
Spherical coordinates 3D animation.
He hasn't shown that. It's Cartesian flat Earth.
Correct.
So what they've done, and I've shown this in the past where I put a protractor, they're using the arc of the protractor and say that's what we live on. Everyone's shown this. Brian has shown this. Everyone's shown this. And so, but the title of this is Spherical Coordinates 3D Animation. Well, nothing could be further from the truth. All you're showing is an X and Y flat disk and a Z.
Not exactly, no, because what makes them spherical coordinates as opposed to XYZ, as opposed to Cartesian XYZ, is that you have a load of diverging lines from a center point out to a spherical surface. And that's what makes them spherical coordinates. Whereas you don't have diverging lines with Cartesian, you only have parallel lines with Cartesian. No diverging lines.
That's not the point I'm trying to make. The point I'm trying to make, if you want spherical coordinates, you need to do it from the surface of a sphere. They're not doing it from the surface of a sphere because, as John has pointed out, from a sphere and to a sphere are two different things. But this is not originating. The vertex is not on the surface of a sphere, so it's not spherical coordinates. Vertex is at where?
Yeah, but I think he's saying this is how spherical is derived from Cartesian in the origin. So you've got the Cartesian labeled XYZ, but he's telling you how the derivation takes place.
Correct. Well, I'm saying the same thing, but from a different point of view.
I get that. I get that.
Between 0 and pi. Let's look at a few more solids where spherical coordinates would be a good system to use. This next one is the portion of a sphere that looks a little bit like an ice cream cone. The sphere reaches out to a radius of 1 at the edge, so we say that rho is in between 0 and 1. For things.
Do we need any more of this?
No, I just wanted to show that, like Danny Faulkner getting angles with the sextant from hell, that all roads lead to flat Earth.
Yeah, okay. Well, we'll end it there. I'll give him another plug, because there's nothing wrong with this guy's description. I mean, perfectly... I didn't have one single criticism of what he said. Did anybody have any criticism of what he actually said?
No, that wasn't the point of the video from
No,
my perspective.
I know, but I'm just asking. No? Well, that's a first.
No, you can't criticise it. He's just showing what it is. Yeah,
Right.
This is what it is.
Okay, well, that's a first. Even when it's our own site, that doesn't normally happen. You can genuinely, a 100% positive comment to this guy. Oh, no, I said he was a bit boring. I take it back. He may not like us sending him people, but, you know, check him out. I mean, he did a good job. I cannot fault his video.
No, when I first watched this, I said, well, he should be on our side the way he's talking. I'm going to post this video. This is good.
Yeah, exactly. Yeah, there's no criticism from us from that perspective, my friend. And in terms of my critique of it sounding boring, that's my ineptitude when it comes to mathematics. Nothing to do with you or your tone or your ability to disseminate maths in an exceptionally good way, but everything to do with me finding maths boring. So Adam will testify to this. As I said, he would have got very moist over your description.
I was just going to say, Adam will probably find that extremely exciting.
Well, the contrast here, not to be missed, is notice how we agree with this guy's presentation, but we can't get the anti-flat earthers or the ballers to realize that you don't get it from a surface that's curved. You see what we're doing here? We're saying, yeah, this guy's spot on. Yeah, because you can't get it from a sphere.
Okay. So there's something I was hoping to talk about today, which I did invite Adam on to have a discussion about, which is something that's been overcomplicated.
1 second, Nathan.
Oh, okay.
Before you go, this is important.
Okay.
What you just watched, what everyone just watched, where that's most important. Because the ballers won't deny that when it comes to, elevation angles to Polaris. They won't deny that they have to use the coordinates in that way, right? But when it comes to what they claim to be spherical triangles, right, that's when you use that. Because that's how they calculate spherical triangles, because they obviously don't measure, can't measure something, a spherical triangle, because there's going to be greater or less than 180 degrees, right? But that's how it's calculated. 3 points, 3 lines from a center point to the surface of a sphere. That's 3 circles with 3 points on those 3 circles, all joined together via arc lengths across that sphere, the surface of the sphere. That's how a spherical triangle is calculated. Why I'm saying that is, you might go, yeah, okay, that's how it works. That's grand, 3 points. Yeah, no. Why I'm saying that is, and this is for the audiences, right? Most of the ballers either don't know that, most of them don't know that, or they don't want to talk about it. Right? They'll send them into a rage. Because that, if they talk about it, it means they're admitting that there's no such thing as a measured spherical triangle, which means there is no sphere. And if they do talk, and if they don't understand what a spherical triangle is, then you have them by the bollocks, sorry for the language, because that means that they think this thing is being measured, and you can show them it's only a calculation. It's purely calculation. So that's where that information is most prevalent, not even with celestial navigation.
Well, that's where the segue to John's point comes in nicely, where you two can coexist without sort of arguing the toss about what they say versus the reality. Where they concede that they have no physical geometry, John steps in and says, well, what do you do in physical reality? Because obviously we're talking about the nature of the world here. So what does happen, regardless of your calculation that you can do in the abstract? We're doing things in physical reality. What are we actually doing, John?
Taking a differential between eye level and where surface or sea level appear to meet the sky.
And you'll need a flat plane to do it.
Well, just one other thing about their spherical coordinates. When they're trying to, and Google has to do this as well, right? Now, I didn't make this public until now. I've only said it to a few ballers, but I haven't made it a big public thing. What Google has to do is you can take, right, you can make a triangle on Google Earth, right? And I've even used the LIGO arms to do this. Now, LIGO arms have to be horizontal. Even on a sphere, those arms must be horizontal for what they're trying to do. I've even used the LIGO arms, right, and made a triangle, then gone to a triangle calculator, and what Google will give you as a hypotenuse is always shorter, even though the other two lengths are exactly the same. The hypotenuse is always shorter than what the triangle calculator will give you. And do you know why that is? Right? It kind of boggles the mind at first for people. They go, what's that about? Right? The reason is that if you take an actual triangle and you place it onto a sphere and you curve those three lines, what you're doing is you're increasing the amount of surface area within the triangle lines itself, because you've curved them. So you've increased the area, the internal area, right, within those three lines, whether it be curved or straight, once they're curved. But so what they have to do is shorten the hypotenuse, which is complete nonsense, right, for their calculation, while keeping the other two lines straight.
Right, you can see that happening on the Street View. Arwin showed this. You're right. Arwin showed this, why that happens in terms of how the maths would actually break down, because the scale changes. If you've got one complete overview of Google Earth, the various different sections of the landmasses are all distorted. Well, if you go into Google Earth Street View, it was Arwin that originally showed me this, and you start scrolling over without changing the scale of what you're viewing on screen, the scale of in the bottom right-hand corner physically changes. In other words, the scale of what's being presented to you, even though it looks like it's the same as you move your mouse over the depiction of the land, the scale that the land's actually represented as changes as you move over it. Does that make sense, Brian? Therefore,
yes.
If you've got a sliding scale of what's being drawn with one line, you're going to get a difference in the value, because the line doesn't have a consistent ruler mark where each one section represents 5 miles. That changes along the line because they have to distort it.
Exactly. And that's what they have to do with their claimed spherical triangles, which is an oxymoron, right? Because there's no such thing. They have to literally shorten the hypotenuse, which is completely crazy because they're keeping the other two lines a straight line, 2 lines basically straight within the calculation. And Google Earth does this. So it's impossible to have a shorter hypotenuse, you would say, right? But they're dealing with the fact that the surface area, when they curve those 3 lines, becomes greater, the internal surface area becomes greater. So they have to shorten the hypotenuse and give you a number that's actually mathematically incorrect, right? To make up for the added surface area that they can't make up for. It's total nonsense. But
however, there was just one more point I needed to add to that, Tenth. I'm really sorry. Hold on. There was one more point I wanted to add to that. Regardless, though, right, when you draw out that triangle, right, you can do the same with elevation in terms of the reference, regardless of scale, to sea level. And you can do that in an elevation profile. But the point is that you can draw out a straight line on that surface on Google Earth. The scale might change to try and wrap it around a ball when they zoom right out, but ultimately the land doesn't. The land can still have a triangle drawn upon it because it's flat.
Yeah, but to make up for when they have to claim that Google Earth have to claim that every one of those triangles is somewhat of a spherical triangle, oxymoron. And because you've just curved 3 lines, or the 3 lines of a triangle, yet they're keeping the lines, yet you must keep those 3 lines joined, you've increased the area within those 3 lines. So the only way for them to make up the area is to shorten the hypotenuse which goes completely against what would be trigonometry if you think of it that way, because it goes against all the triangle calculators. So you're keeping the adjacent and the opposite the same exact length, but you have a shorter hypotenuse. It's mathematically incorrect, basically. But that's what they have to do. If you look at a polygon drawn onto Google Earth, check out that and then go and use the exact same, use just two distances to create the polygon, and remember your distances, and then go to a triangle calculator, and you will see that the triangle calculator will be greater in length all the way around the triangle than what they are giving you, which means they're not giving you a spherical triangle. They're lying. They're literally lying via maths.
There's a quick death for all of this. Anytime they use the word angle, that must have a shared baseline with GP and GP. GP of the observer and GP of the star in question. That baseline, that adjacent, must be one baseline horizontal, and it must be shared. As Rob Durham showed in the SCAT program, if it's curving away, the angle changes. So since the angle doesn't change, it's over. You're using a flat Earth.
But yeah, no, but this is slightly different. We're talking about a triangle drawn onto the surface of a globe.
No, I understand. I understand.
You know what I mean? This is slightly different mathematics. But
I know. I've changed
right.
over.
Yeah.
I've changed over, Brian. You killed it on that one. I'm just saying, anytime they mention angle, just like they say spherical triangle, which there's no such thing. Well, anytime they say angle, you say, what's an angle? Okay, and then it must be, even in the way they show it, a shared baseline, because the GP and the GP must share it. It has to be. You subtract from 90.
Indeed, you're going to need a flat Earth for it, no matter which way you dice it. Right. Excellent stuff. There's nothing else to cover in the show. We've covered that. 80 people watching, though, so please smash the share button. I'm sure there was something else I wanted to cover.
You're going to need a flat Earth for that spherical surface.
Hold on, there's a plug I wanted to do. So,
there was something you were going to say a minute ago, Nathan, before
I know what that is. So there was something else on top of that. I'll come back to Brian Leak in a second. Okay, so Righteous did a very poor job. No offense to you, Righteous, of actually plugging this in the pre-show. So Righteous is putting together some nice, concise, less than 10-minute videos on biblical cosmology, as he just said. So subscribe today. This is one of our moderators who puts in a hell of a lot of work to this show. So show him some love by going to his video and subscribing, listening to the video, passing on a comment, give him some algorithmic love. But one of our moderators, that's Righteous Force, is now putting in a lot more work to his videography. So it'd be nice to show him some love. So yeah, check him out. There's a link going by in the live stream right now. That was the other thing I wanted to cover. In terms of Brian's recently made a video, although he's made quite a few recently, claiming we're charlatans along a very Joran-esque line. However, in this instance, he's picked up on a very key detail. Now, this isn't necessarily flat Earth, although it is. You'll see why at the end when we connect the ontological primitives back to a flat plane that we've been lied about. Well, there you go, I've done it already. But the discussion point that's being alluded to by Brian, which made me want to appeal to him more, as opposed to just put him down and say you don't understand, was a convolution of the usual light as a wave versus light as a, I'm going to put it in inverted commas, particle. Yeah? Chunk of discrete whatever. You know, there's a notion of light that's been misconstrued and then reinterpreted and then used as evidence for a background medium called ether. That's the background to what we're about to get into. If that floats your boat, then great. Anyway, I wanted to, when Adam arrives later, he may do this with this, explain precisely what has been done to light to make it into a quote-unquote wave, when a lot of the quantum mechanical ideas of light do have the description of a wave, sort of, in those descriptions. So how can it be that it's not a wave when everybody's still describing aspects of light with wave terminology? And hopefully an understanding of this will lead you to appreciate who's being a charlatan and who isn't when it comes to these descriptions of fanciful background mediums called ether. Okay. Now, the reason I wanted Adam to be involved is because wave function is where this path begins. The description in maths of something called a wave function. Now, in Brian's video, he takes a section of Quantum Eraser describing the double slit experiment with an example of one aspect of the experiment. But after he says that, corrects himself because his specific example is not experimental in nature. It's merely an aspect of what's being studied in the experiment when you detail diffraction, or I'll say it with its technical term in this aspect of the experiment, wave function collapse. So if you want to get to the nitty-gritty of that particular experiment when you're talking about the double slit experiment, the only phenomena that you can ascribe correctly scientific validity to is knowledge of which path being the causal influencer and wave function collapse being the observed phenomena. That is the experimental setup and the cause and effect relationship that has validity offered. However, QE doesn't use that. He uses, in quotes, a photon hitting a photographic plate as his example. That's his example. Now, he's debunking Maxwell, but that isn't the point either. The point I want to focus on is, how do we get from QE's description of a single photon hitting a photographic plate to light as a wave? Well, when you look up light as a wave, or Schrodinger, or quantum mechanics, or even wave function itself, I did that today, into, say, YouTube, what you'll get back in terms of the suggestions is a load of people describing quantum mechanics, some badly, some with heliocentrism in mind. Nevertheless, what I want to explain now isn't anything necessarily to do with quantum mechanics. It is, but it's not the raw mathematical aspect of where wave is misinterpreted. The wave comes from the notion of the photon that hits the plate. So you've got a light being fired, it goes through a double slit, and on the other side of the double slit, you've got a photographic plate. Now, when you fire one, what I'm going to call photon, at that plate through the slit, it hits in a particular position. Now, if you're to repeat that process and just keep firing photons one at a time, yeah, it will build up, providing it's actually set up correctly and you've got a diffraction pattern. You're going to get the light hitting at various different points. Now, what the expected behavior, what makes this a phenomenon, is that the expected behavior is that when you fire a light, let's imagine you've got a torch, and we're going to scale it up to the point where everyone can understand what's happening. You've got a torch, and you've got two doors in front of you, and you're firing the torch, right? Now, your expected behavior is if you fire the torch through door one, the torch light will hit behind door one. And if you fire the torch through door two, the light from the torch will hit behind door two. That's your expected behavior. Now, in the case of light diffraction, that isn't what occurs. Instead of you firing the light through door one and it hits behind door one, it flies off to what we're going to call position 7. Yeah? Far off to the left. Or flies off far to the right. Because in this instance, you're firing the light just between the door frame. So it's not quite hitting door 1 or door 2. You don't know which one it's going to go through. Let's just make it crude so people can understand at a big scale. So in that instance, where the light hits, instead of with a torch that's firing the light continuously, we now change it to a light that's firing one chunk of light at a time. Now, when you fire one chunk of light at a time, you end up with this probability of where the light will hit. Now, that probability of where the light will hit is quantifiable mathematically. It's a distribution of probability. Where will the light hit next? Now, that, when you write it down and put it into a graph form, is called a wave function, aka also known as a probability distribution graph. And it's showing in graph form where is most likely to hit versus where is least likely to hit. And that wave function gives you the distribution of where the light, when you're firing one at a time, might hit next. Will it go through the door and hit directly behind the door? We don't know. It might hit a position 1, it might hit a position 7, it might hit a position 4, it might hit a position 2, and so on and so forth. You don't know where it's going to hit. It's distributed on the photographic plate, and the calculable value of what's being distributed is summarizable by probability. So probability distribution is known as, mathematically, wave function. Now, this explanation has been deriving our frequency of light for quite some time. It's a convention we use. Now, when you describe the frequencies of light, you can understand how that can be misinterpreted to mean that light is physically wave-like. Propagation through a medium, a wave, when in reality, where the light hits when diffracting has a probability associated to it that can be graphed, and when graphed, to describe it with the convention of maths to another human being, kind of looks like a wave. But it isn't in reality a wave. It's merely the distribution of the light and the probability thereof when diffracting. So, with all that being said, we can understand, empathise, when our compadres on the flat Earth battlefield misinterpret this distribution of probability as a physical wave for things to propagate through, or a medium that will create a wave when light is propagating through it, to make it more accurate. Anywho, it isn't. Light's not a bloody wave, as you can probably figure out from me describing the wave function and how it is a probability distribution of impacts of light when diffracting, for example, with a double slit experiment, but the example of a photon, singular, hitting the photographic plate. Because when that happens, i.e. one photon hits the photographic plate, equivalent to you shining your torch once, and only one bit of light goes behind the doors. When that occurs, you no longer have enough information to form the mathematical wave of probability distribution. In order to form that wave mathematically, you need more than one point of impact on the photographic plate, because you're going to be building up the wave based on the likelihood, that's probability, of where the next flash of your torch will hit behind the doors. Well, if you've only got one flash of light, one point of impact, you cannot form a wave function mathematically to then reify it into something that's going to be a medium for light to bloody transfer through. One impact means no probability distribution to describe mathematically, no wave to extract. That's it, I'm done.
Well, whenever you're trying to demonstrate this wave that both flat earthers and ballers are claiming, there's two axes. There's two axes. Yeah, but there's two lines. There's an X and a Y axis being drawn out. What does each one of those represent? Because the way I've seen it depicted is X is space, or the particle's position in space, and Y is time for both ether components and relativity components. So it's space-time.
The word you're looking for is axes.
Majoring on the minors there. What you're saying is they're replacing one of the axes with a fourth dimensional concept when describing probability distribution. How do they put a timing aspect into it?
Well,
Oh,
not
they
just
just
that.
just
but
told me they
the-
relabel an axis. You've just told me.
Right.
I knew
but
that,
not
Brian.
Go on, John.
Not just that, but the way both the flat earthers who purport ether and the heliocentrists that purport relativity are describing a particle's position in space and time, right? And they're using a two-dimensional coordinate system to reify a wave. They're both doing that.
I see. So
Well,
you're saying that.
How could they?
Go on,
Sorry,
right,
go
Neil.
ahead.
No, go ahead and ask.
I was
Go
going
ahead.
to say, how could they? What is?
Probably on Thursday, maybe Friday. We'll see if we get there, Neil.
What
Shit.
I'd like to know is, how can you make a wave out of two dimensions?
You can't. But you plot one axis as time, and then the position in time is going up and down on the graph. Therefore, a wave. I mean, it is just that crude, is it not, John?
You say me or Brian?
John, you. I'm saying if you
It is
reposition.
that
Go on.
But both the ether people and the relativists are doing that. And they're saying that they're against each other, but they're not. They're saying the same thing.
Yeah.
Could I be permitted to make a parallel here that may be
I'm going
incorrect?
to go with no.
All right. Well, I'm going to do it anyway, right? But correct me if I'm wrong. Is this not a parallel to creating a sphere from the dip angle between two parallel horizontal planes? Is this not the same type of thing where you can create a sphere out of it, but it's not a sphere?
Well, I mean, you could say it runs parallel in terms of the type of hijacking, but no, because you're replacing a dimensional axis with a time axis, is John's point. But John's further point, that even that's majoring on the minors, is that both heliocentrists and ether believers both have this same substitution to reify space-time into a physical, tangible wave of a medium, when all they're really doing is substituting an axis. It doesn't mean that you've got something bouncing up and down on a graph. That's not physical reified. That's not reifiable.
Yeah, because I know that in space-time, they take away the z-axis and add in time. So they remove an elevation, let's say above and below the xy, and they just call that time.
Yeah, so do ether believers. They say that there's no journey, right? They say that there's no journey for the light. It's just the perturbation through a medium, which would have a speed also. That was another point that John made. But there we go. Brian Leak went to a load of definitions for, what was them? Propagation, and went to plants. So I just went to the physics definition, which very specifically details the speed. Because he's like, yeah, which it's saying it's not got a speed. Here's a load of definitions for propagation of plants. Yeah, what about the physics definition, Brian, that specifically details its speed? They don't realise where they're being swindled by Witsit, and this is the swindle, that replacement of that axis with a time axis. Yeah, it doesn't mean it's got a journey. No, it means you've substituted that axis for time.
Well, I charged Austin with that in the debate with him. That was the charge I held against him, that he was trying to just replace what was already there, as opposed to oppose it, if you understand what I mean. And he denied it at first, but towards the very end of the debate, he admitted that he was looking to just describe all that differently.
Yeah.
But all that is actually what they describe as space-time.
Yeah, they've been doing it for years. Globebusters have been doing this since day one by wanting to retain gravity. Ever since I've ever known them, they've wanted gravity to be real.
Yeah, because let's be honest, when Bob came out with that thing on the Netflix documentary, the fog gyro and the 15 degrees per hour, like, I mean, he was fully aware of what he was doing. Like, nobody was told this was going to happen. There was no conversations had with Bob and other people like yourself or QE or me or anybody in the arena. He just came out with this on this on the biggest platform we could find, and said it proves the ether. You know what I mean? So straight away there was an attempt at the hijacking of something.
Yeah, they're affirming the consequent formal logical fallacy. They, globe earthers, use the fog gyro or gyroscopic 15 degrees an hour drift to claim that Earth rotates underneath the fixed frame of the gyro. So the cage moves, the gyro stays in fixed space, the drift that you see is 15 degrees because Earth's turning underneath. That's Coriolis deflection, right? Okay, but in order to assert that, if you did see a 15 degrees an hour drift in a gyro, then Earth is rotating underneath. Earth's rotating underneath because we see a 15 degrees an hour drift in a gyro, right? Well, you should substitute in ether. If we see a 15 degrees an hour drift in the gyroscope, then we have an ether drift. We have an ether drift because we see 15 degrees an hour drift in the gyro. So when you say he's hijacked it, well, what he hijacked was their logical, Bob Nodell, rests in peace, hijacked, was they're affirming the consequent formal logical fallacy that affirmed the consequent with gyro drift and Earth turning underneath and just substituted in ether drift for the same affirming the consequent. Identical, in fact.
Yeah, he just took away Earth rotation and added in drift, ether drift.
Yeah.
That's all he did.
But he started off, but his declaration to Netflix was that he was going to disprove that. In other words, he was going to fire up this gyro and it wasn't going to show any drift, therefore disproving the affirming the consequent fallacy that was going to prove it through fallacious reasoning. That wasn't necessary, but that's what he attempted to do. In other words, the way it's positioned at the beginning of the Netflix show is if it doesn't show 15 degrees an hour, then we're not turning underneath, or the cage isn't attached to a gyro in fixed space that's turning underneath because we don't show the drift. We did show the drift, but that doesn't mean Earth's turning. It means that we've got ether.
How could they purport anything when they haven't defined what ether is?
No, that wasn't what he said. That wasn't what he said. He said, uh-oh.
Wouldn't a malfunctioning gyro have drift?
Maybe a malfunctioning gyro drift. But what you'd need to assert, if you're claiming that Earth turns underneath the fixed frame of a gyro, that would physically mean that the ground moves and the gyro remains in fixed space at the tune of 15 degrees an hour as claimed with Coriolis. But that means Earth's turning underneath aeroplanes. And
that's exactly where I was going.
yeah. So that's what I tried to level at Bob after he went on Netflix. Look, okay, yes, this has been a complete disaster from your perspective, and now you're affirming the consequent for ether. Meanwhile, just take it as read. They're saying, thanks, Bob. That's very useful. Now, maybe pride precluded him from doing so, but thanks, Bob, for what? Proving Earth turns underneath the fixed frame of a gyro at 15 degrees an hour. So Earth turns underneath planes, because they've got gyros on board, right? So we'd see the 15 degrees an hour underneath an aeroplane. That would mean that a flight from Charlotte, North Carolina to Los Angeles would only take an hour and a half, because Earth's turning underneath the gyro at 15 degrees an hour. 2 reference frames. What's that you say, Dan? They're ruined? Yeah, they're ruined when we show that there's no drift, like you showed that there was no drift. But they claim there is 15 degrees an hour of it. They claim Bob proved it. And if there was, flight times would be shortened. So just take it as read. Okay, finally you admit we are supposed to see 15 degrees an hour. It's amazing when so many people tell us that Earth and atmosphere spin together and there's no drift to see. But yet Bob's simultaneously proving there is a 15 degrees an hour drift as Earth turns under a gyro. That's devastating because flight times would be reduced and they're not. But Bob didn't do that. He went, oh no, it proves ether. With the same affirming the consequent formal logical fallacy. That's how he chose to spin it. So you just end up with a false dichotomy. Either the 15 degrees an hour drift in a gyro that would have Earth turning underneath flights is proven by the gyro when Bob fired it up, or 15 degrees an hour drift of ether when we see drift in a gyro. Like, what? It's neither. That's a false dichotomy. So all Bob managed to do was set up a massive false dichotomy for all of Flat Earth and Globe Earth to partake in via Netflix, rather than pointing out that it's an affirming the consequent fallacy for us and them, us being the ether believers in this example, which we're not.
Well, if you talk, like logically, if you take it to the Ballers' claims, and I did this some while ago in a video, like they're claiming that the plane moved flying east to west or west east in those two directions is being carried along by conservation of momentum, right? That the Earth underneath it is rotating, underneath the plane is rotating at 15 degrees per hour, and the airplane is being carried along by that momentum. You know, like this nonsense where an airplane takes off backwards, right? Right, it's that nonsense, right? But there's three fiber optic gyros in the inertial navigation system of an airplane. So, like for roll, pitch, and yaw. So the one for yaw, at least the one for yaw, must show a 15 degree per hour drift. It has to, if the gyro is picking up 15 degrees per hour of Earth rotation, because that would mean the one in the plane has to also do that if the plane is also being brought along by 15 degree per hour conservation of momentum nonsense.
Okay, but if I take that as read, well, let's just take it as their anti-flat Earth glurf position in terms of this, which is the globiolus effect, right? Well, if I take their position as read, okay, fine, I take it as read. You're saying Earth and atmosphere move as one, and therefore we're going to see a very minimal deviation in the plane because the two are essentially as one reference frame. Okay, so you're saying that I sit on the ground and watch a plane take off, and I do not see any drift. No Coriolis to be observed at 15 degrees an hour then. Correct?
Yeah, that's our claim.
Well, then there's no Coriolis effect, because the anti-flat earthers are making it explicitly clear that while they beg the question that Earth and atmosphere move together, and there's no Coriolis effect to see, that would mean that the biggest claim that there's proof of globe Earth turning, that's Coriolis effect to be observed, isn't being observed according to them. No, that's right. No, so we're clear. The globe Earth claims we'll see a drift at 15 degrees an hour. Bob's being ascribed thanks for proving that the Earth turns underneath the gyro according to them. But also they claim that there's no effect to see, Earth and atmosphere spinning together, no drift to observe. Which is it? Well, the answer is neither. We're just not turning. There's no effect to see. That's true. Yeah? Earth and atmosphere beg the question of moving together? No, that's a first and second law of thermodynamics violation. So that's definitely not the case either. So there's no effect, and there's no proof we're turning. Oh, then that's just net zero. There's nothing to see here. That's the end. There's nothing to see here. There's no proof we're spinning because there'd be drift. 15 degrees an hour of it. What, there isn't any, but we still assume we're spinning? No, we don't.
Yeah, that's why when I did the couple of videos about the London to Accra flight, the ballers hated it. They got thousands of views on them. And the reason is that they hate it because within their actual claims, there has to be a drift between London and Accra. There is no way around it. That there is no conservation of momentum being claimed by them, with the exception of the latitude the plane it takes off at in London. So when the plane is flying to Accra, the pilot has to account for 15 degrees per hour of a drift of the Earth underneath them, and that 15 degrees per hour will be, as they're flying south, will become a much greater distance in miles because they're flying towards the globe's equator, right? So that means that the plane has to not fly due south, as it does in reality, not fly 3,000 miles, as it does in reality, to get from London to Accra, but instead fly east-southeast towards South Asia and fly over 6,000 miles. Now, they don't like that. And when I actually said it to Ben, and I don't think a taboo conspiracy, I don't know if he fully grasped it. That, remember the thing he was showing with the stars? That if you could get a recording of a flight going due south, and the stars are not doing what they should be doing, because if in that scenario the stars shouldn't behave, I won't go into it now because it confuses things. But the stars' behavior will show whether the Earth is rotating or not. In other words, the Earth has to rotate underneath the plane in that north-south direction. Within their, I have to use the word model, right? The Earth underneath the plane has to rotate. right? There is no conservation of momentum. They can't claim any of that north to south. So that means that if the pilot is flying and they don't have to make accounts for out rotation, it's because it's not rotating. But also the stars would show that it's not rotating. If you had a video of the stars when you were flying directly north to south. You could do south to north as well, but north to south I think is a little bit better, because it's an increasing amount. With the 15 degrees per hour is an increased amount in miles. So there's no way you could hold a direct north. Either way, north, south, north, it doesn't work. But that's the whole point of it. But the stars would show that this is not happening.
I would like to point out. I would like to point out that there's two assumptions being made in this affirming the consequent that they've used, and one is a measurable R value to have a non-inertial turning reference frame and a point of rotation for it to turn. So we're going to need those before we can really move forward in the argument.
Okay. Well, that's all right. Where are we going to get those from?
I know where I could get it from, but
Hello, Adam.
Afternoon, guys.
Did you get my message earlier?
Yeah, so I've joined a bit just so I could figure out what. I don't think there are those numbers. I think when we're looking at making a description, and I'll bore you with their details, but how we work out wavelength, just say with a ruler and some grating, is that you're going to then approximate to. I don't think you derive the function from the direct hits, because it's a wave function. So you derive it from the wave that you've derived from the grating that you can measure, as opposed to taking individual plot points, turning that into a graph, a wave as it represents the wave, taking those individual data points, putting it in. That's not how you calculate the wavelength of it. So it's calculated in a different way. So I don't think you'll ever get that specific photon position data.
Well, does that mean that I'm just using a crude analogy? Or does that mean...
So, yeah.
Okay. Does that make my analogy wrong?
No.
Fine. But I can't literally go to a maths textbook and find it described outside of quantum mechanics because of the way it's being derived. Is that what you're saying?
I mean, yeah. I think you're not going to find that photon 3 hit here, photon 8 million hit here. You're not going to have that cumulative data to build your wave pattern up from. I think that's what he was after.
No, it's what I was after. I was asking for it. It was just something I thought, if I can just find somebody that's not me. I mean, I just did it for myself today. I don't know if you were listening.
No, I've only just jumped in.
No, fair enough. I mean, earlier in the show, just because Brian, whatever his face is called, was essentially calling QE a liar because he went and called his example an experiment by the way he'd phrased it, because he was using the double slit as an example, but by exampling one photon hitting the photographic plate. So he corrected himself in what he was saying and saying, well, it's not an experiment, it's just an example. And the way he'd said it, I knew straight away that what he meant was, well, me describing one photon hitting a photographic plate, that's not an experiment. It's just an example. But he's already qualified what he's saying as though it's experimental by phraseology. So he's just making one minor correction. And Brian's picked up on it and gone, look, he's just a liar. In one breath, he's calling it the double slit experiment, and now he's saying it's just an example. It's like, no, his example of one photon hitting a plate is just an example. And the example is being contextualized from within the double slit because that's where that happens or where that's being studied. Do you see what I mean?
Yes. Well, where's the science in the double slit? There's nothing wrong with it, yeah? But you can also demonstrate things with it as well. So, yeah, I think, is this where we're at? They're just those subtle nuances of sentence constructing to try and make a problem to then have us correct it. I'm fine with that. You know, if I've ever misspoken, I've got no problem with going back and adding clarity. Yeah, even correcting myself if I've misspoken. But is that really...
This is where they're at, Adam.
Yeah.
This is where they're at.
That's brilliant, really, isn't it? In terms of actually knowing whether you're on the right path, all your opponent's got is that, you're not a lot to worry about, have you?
Sure, but what it tells me is that he's majoring on the miners, and I don't even mind him having a misapprehension in that regard. You know, it's fine that he doesn't quite get that when QE's detailing that particular aspect, he's detailing how the single photon hits the plate and not the cause and effect relationship to justify calling it an experiment. But the reason he's detailing one impact is to say you can't derive a wave function from that single impact. Therefore, where's your wave? It doesn't exist anymore. That's the point. But he hasn't picked up on that. He's gone, look, he's called it an experiment, and then later said he's just giving an example. What a liar. You're like, no, but clearly you want to know this stuff. You clearly want to get a better grip on it. Well, good, and that's admirable. Hence me taking the time today in what should typically be flat earth debate to explain it to him, or explain it generally so that people understand the derivation of wave function and how that can be misinterpreted into a medium. And then, you know, John's gone to explain how you just substitute one of the axes. Great explanation. Good addition. You know, we're all working nice and coherently here. Cohesively, whatever the word is.
Yeah, you can't create a wave function collapse pattern from just one photon.
And that was the point that was being made.
Yeah.
Exactly.
Yeah,
but
it's just a complete misunderstanding, and then calling him a liar.
Yeah. And that's fine. Sometimes, you know, your ignorance is fine. Not understanding this stuff is perfectly acceptable. No, that's fine. No one's going to take the mick out of you. It's complicated stuff. But to say, look, he's a liar, and then major on the miners when there's a particular point being actually made, it's like, no, why didn't you grasp his point? He's trying to explain to you how Lite's being hijacked in this regard so that you can better understand it for yourself. But instead of taking heed, what's going on?
Well, maybe it will help him out if I point out that the double slit is a recreation of a naturally observed phenomenon. And then you have experiments using that setup also.
Yeah.
I think there's just like a witch hunt on. Sorry. Go on out.
Just from the sound of it, it wouldn't matter refracted, would it? Because he's not interested in anything other than has one of us misspoken. Can something we said be held and used against us for us to have to? Because I don't see anybody out there preaching and standing by these things. So at best, all they're going to do is, and thank you. There's nothing wrong with a bit of peer, a little bit of review. Go back over your back catalogue, and if you've, as has been pointed out, misspoken, then it gives us the chance to correct it. Because from what I'm hearing here, there's no theological difference in what QE's being, asked to correct. It's exactly the same thing he's showing, demonstrating. The experiment's not changed. He's just had it pointed out that in the middle of a sentence, he's used the wrong phraseology. Is that where we're at, Brian? Not yes, Brian, but Brian Leake. Is that what you've resorted to, son?
With that, I'm going to say, if you're watching this on either Nathan Oakley 1980 or Nathan Oakley Programming streams, then stay tuned, as there will be an after show to follow. Unfortunately, though, if you are watching this live, this is where we bid you farewell. So another huge, massive, enormous thank you to both Discord and G+ panels for making the live show possible. And of course, a massive thank you to all of you for liking, commenting, sharing, subscribing, joining as a Nathan Oakley 1980 channel member, and all that good stuff. I've been Nathan Oakley, and I will see you all in the next video.
What a lovely day!